Hello students, good morning. Welcome in lecture number 4. I hope you all are safe and healthy at your home. For our better safety, please follow the government's some guideline for today's situation COVID-19 pandemic. Now we start our lectures. We see the topic in thermal application. In last lecture, we studied flat plate collector. Now, in this lecture, we studying CPC, cylindrical parabolic collector. You see the main parts of CPC: central heat pipe, parabolic shape reflective collector or reflective coating or mirror, and collector supports. We see the construction and working. When temperature exceeding 100 degrees Celsius are required to be achieved by cylindrical parabolic collector. It is noted that if we have exceeding temperature below 100 degrees Celsius, then or 40 to 100 degrees Celsius, then we use flat plate collector. And if above 100 degrees Celsius, so that is this instrument CPC is used. And if we exceeding above 400 degrees Celsius, then next our instrument paraboloid concentrating collector is required. So it is used for the temperature range 100 to 400 degrees Celsius. It consists of a concentrator and a receiver. The concentrator shown in mirror reflector having the shape of cylindrical parabolia. This is noted that the shape of receiver shape is cylindrical parabolium. It focuses sunlight on its axis where it is absorbed on surface of absorber tube and transferred to the fluid concentric glass cover help in reducing convective and radiative losses to the surrounding in order that sun rays should always be focused onto the absorber tube. The concentrator has to be rotated. This method is called tracking. So this is the working of cylindrical parabolic collector. This is the side picture of or actual picture of CPC. Actual photos of CPC, and many CPC are together each other. I have some videos of this cylindrical parabolic collector. It is attached here. Solar radiation absorbed at concentrated and then they absorb on receiver. Parabolic concentrating collector. sun field. Construction. Shape of this instrument: cylindrical parabolic. This type of solar radiation is received at concentrator and absorbed at receiver. Fluid in passing inside the tube, which heats up the fluid. Fluid is passing inside the tube continuously. Cylindrical parabolic concentrating collector. Two axis tracking system. It is move with movement of sun and solar radiation. From this system, the sun is in line with focus. Our next and last instrument for thermal application and storage, paraboloid concentrating collector, PCC. Paraboloid concentrating collector. We see the main parts of this PCC: receiver, declination axis, concentrator, declination drive, jack screw, supporting base, polar axis, polar device, jack screw, and counterweight for the better result. We see the some other photos of PCC. It is actual photo of paraboloid concentrating collector. Now we see the working of paraboloid concentrating collector. We discussed above, when temperature attainable above 400 degrees Celsius, then paraboloid concentrating collector should be selected. It consists of a receiver and concentrator. The paraboloid concentrating collector is costly and therefore used for special purpose and having a supporting structure, polar axis and declination axis. These collectors are used where temperature about 400 degrees Celsius are required. This collector requires two axis tracking system so that sun is in line with focus and the vortex of the paraboloid. I have some videos of this instrument which is attached at here. Paraboloid concentrating collector. Sun rays is focused on paraboloid receiver. Here collector requires two axis tracking system so that sun is in the line with focus and the vortex of the paraboloid shape. Take care of you and your family. Thank you.